Okay, so I want to know the dimensions and the perimeter. That is, the dimensions and the minimum perimeter for a rectangle with area 98 feet. And I'd like us to use substitution and differentiation to accomplish that. Just for fun, I'm going to draw a rectangle. We usually call this length times width, but we're going to call it 8 times y right now for area. So our formula for area, normally length times width, we'll let it be x times y. And we'll plug that 98 in for a. Now we're talking about a perimeter here. We have a formula for perimeter. It is, well, usually 2 lengths and 2 widths for the distance around, but here we'll call it 2x and 2y. This is too many variables, and we are going to use substitution. We could not use some other method. Anyway, let's go ahead and solve for x. If I want to solve for x, I'm going to get y out of there with division. I've got x is 98 divided by y. What I'm going to do with that is I will substitute that into the other equation. When I do, what I have is 2 times 98 divided by y plus 2y. Let's clean that up a little bit. That perimeter would be double 98 over 1 times y. So that's 196 divided by y. And if I'm wanting to differentiate this and have a minimum, well, it would be easier for me to go ahead and rewrite this as opposed to using the quotient rule. So we'll call this 196 y to the negative 1 if I want to move this y to the numerator. I just make the power negative. Now it's not so bad. So the derivative, say p prime, instead of that 196 y to the negative 1, using your power rule, that's negative 1 times 196, and we drop the power to negative 2. The derivative of, what is it, 2y is just 2? Okay. Well now, okay, we're going to set this equal to 0 and solve, because we need to find those dimensions. If I do set this equal to 0, I've got a little work to do to solve the mystery of what is y. I would move that y squared back to the denominator to make that power positive. My next objective, well, I could go about this in one or more ways. One thing I usually like to do is go ahead and get rid of fractions. Let's undo that division using multiplication, and we'll treat all terms the same. This is our objective, to make that go away. Of course, we do need to treat all terms equally. So I've got negative 196 plus 2 times y squared, and 0 times y squared is still 0. Now then, to get y completely alone, I would move 196 to the other side, and I would move it using addition. Next, I'm going to divide by 2. So I've got y squared is equal to 98. We undo the square with the square root. Normally we would say plus or minus, but we're talking about a physical object, and that distance will be positive. Okay, well the square root of 98, that's not a perfect square. But we do know that 2 goes into 98 49 times, and we know that 49 is 7 times 7. So we get to take out a 7 and leave behind a 2. That means that y is 7 square roots of 2. So we wonder, well, if y is 7 square roots of 2, what's x? We'll plug it back in. X is 98 divided by y. So x will be 98 divided by 7 square roots of 2. Excuse me. And that could be reduced. We can call that 14 times 7 divided by 7 times the square root of 2. We find that x is 14 divided by the square root of 2. If we rationalize the denominator, we've got 14 square roots of 2 divided by 2. So x is just 7 square roots of 2. Well, we've got the dimensions. We know that x is 7 square roots of 2. We know that y is 7 square roots of 2. What about the perimeter? Well, okay, so my rectangle is in fact a square because all sides are the same. Not that you can tell this from my picture. Well, that perimeter, whether you use the perimeter formula or you just add up all the sides, we've got 7, 7, 7, and 7, all square roots of 2. Well, that's 28 square roots of 2 for our perimeter. Well, a question could be, is this really a minimum? To find out, we would look back to our critical number. Our critical number came when we set our derivative equal to 0. And upon setting it equal to 0 and solving, we got y was 7 square roots of 2. Okay. So now we could test a number from each side of 7 square roots of 2. We would test it by plugging into that derivative. Anything less than 7 square roots of 2, that's anything less than about 9.9. Let's just say I want to test the derivative of, why not call it 5? And then something bigger. How about call it 12? Why not? The derivative was negative 196 y to the negative 2 plus 2. We rewrote that as negative 196 divided by y squared plus 2. If we were to plug a 5 in there, that would be negative 196 divided by 25. I'm not sure what that is, but I know it's more negative than 2 is positive. I know that if I do plug 5 in, negative 196 over 5 squared plus 2, whatever that is, it's going to be negative. So what that tells me is that our function is decreasing here. And if we were to go in and check, well, what about when we plug in, say, 12? If we did plug in 12, that would be negative 196 divided by the square of 12. Well, that's negative 196 divided by 144. I'm not really sure what that is, and I'm feeling a little bit worn out by now. But it is negative 1 point, I'm not sure what, plus 2. The point is, that's going to be positive. So our function is increasing. And then, yes, it really is true. We've got a minimum. Okay.